Guys, this is Mark Windholtz talking testing, friend or foe.
Well, we're going to talk about testing, cables, and chains. My name is Mark Windholtz. As he said, I'm from Cincinnati. I'm a freelance developer. My company is Agile DNA, and that's my email address if you want to talk at some point in the future. I came to Elixir through domain-driven design. My interest in domain-driven design, I find that Elixir has facilities in it that make it much more directly, the patterns of domain-driven design much more directly implementable. So I'm very happy to be in Elixir these days. I'm also an early adopter of extreme programming and have been doing test-driven development since 1999. So what are we expecting when we're testing? We're expecting the tests to give us confidence in our code. We want to know that when they're running, that our tests are in good, or our code is in good shape. But sometimes odd things happen. The tests break. And well, that's kind of fine. We're doing red-green refactoring. But when we look at this stack trace, we see, wait a minute, there's no test there. We don't know where to start. What actually failed? The only clue we have is down here deep in the stack, we have our token repo server that failed. So, okay, let's explore that. We get together with our programming pair and we dig into that code. It's a little mysterious why this is failing. All right, but we want our tests, they give us confidence. So we'll change some things, run the tests again. Hey, that worked. We're back in green. Check that code in. We fixed it. Cool. So we spend 10, 15 minutes, 20 minutes, could be an hour trying to figure out what this was. We must have nailed it. Go back to work. Tests are running green. We're being productive again, moving through our day. Oh, man. We fixed this. We checked it in. They were green. It's the exact same stack trace. Oh, man. So what we have is some flaky tests. So after having spent that 30 minutes debugging and changing things and really pretty much accomplishing nothing, we have to start asking ourselves, are these tests helping us or are they getting in our way? Are they was this just a waste of time? The rumor is that good tests, the promise of good tests is that they enable agility. They will enable us to do good design. They get us faster feature delivery. And ideally, or eventually, making more money. That's the point. But, oh man. Well, some people say that just flaky happens. We just rerun it. And I've seen this on teams in the CI machine. On CI, the test fails. Okay, just go rerun the thing. Okay, it worked once. We must be able to deliver now, right? I don't like that. And I break down the tests into two different types of developer tests, cables and chains. Cables connect two faraway points. They answer questions like, is the UI and the database connected? If a cable fails, you have to replace the whole cable. A cable like this, you cannot just tie a knot in it. You can't just weld it back together. It's a big process to change this cable out. J.B. Rainsberger calls these integrated tests. They assert that things are connected correctly. We try not to assert business logic in a cable test. Why not cable everything? Well, supposingly you have X branches of logic in your code. That means you're going to have 2 to the X paths. That means you need to write 2 to the X tests. Well, that's going to be a lot. Unsustainable. Your setup is going to get very intricate, and your tests are going to be slow. This is just not sustainable. It's not going to work. And the other thing is when you go to update your design, you find a new requirement that requires you to change your fundamental model. You're not going to be able to. Once you have a lot of cable tests, your design becomes stuck in concrete. Agility is out the window. So the other kind of test is a chain of links. So if your links are strong, they make a strong chain. Good unit tests are like a chain of links. Unit tests should assert business logic, every conditional branch, and the various value ranges in that unit. So about this time, as I was putting this talk together, I thought this was a great image, but I started getting a little uncomfortable. This kind of chain still connects 2 points, doesn't it? The links are very integral to everything working together. It's not the visual metaphor that I really am after. The visual metaphor might be better is chain link armor. In chain link armor, each link protects one tiny little part of the soldier's body. Each one of those, if it's damaged, it can be replaced independently. It's not, the whole chain is not going, the whole armor is not going to fall apart if a couple of them are missing, but you can replace them independently. Each one of them is a unit. What is a unit? Michael Feathers, in a blog post called A Set of Unit Testing Rules, gave us a hint at that. Basically, he gave us a number of rules that say when a test is not a unit test. And I call this Feathers' razor. He's going to shave away everything that is not a unit test, leaving us with what is. So what does he say? It's not a unit test if it can't run in parallel. It is not a unit test if it needs the database, if it needs the network. It is not a unit test if it needs the file system. It is not a unit test if it needs the environment. So when you go through these, you kind of wonder, have I ever written a unit test in my life? In Elixir, we have a couple of extra things to watch out for. I find bites us a lot. System time. If your test or your code relies on system time, it might not be a unit test. Application get environment, or the Erlang scheduler. This one kind of snuck up on me as I was working through this. It becomes, it's not a unit test if you're using the scheduler. To sum up Michael Feathers' rules, unit tested code has no side effects. Well, we're kind of in luck. Functional programming should have no side effects. When the return value of a function should be determined completely by the arguments you pass it. A function with side effects is a procedure. And a procedure may use the database, but the database, the return value you get from that may be what's in the database, or it may be that the database doesn't exist. It's non-deterministic. This becomes really hard to test. So, pure functions have no side effects. Tests of pure functions are unit tests. Cool, but what happens if we actually want to talk to something? Well, Gary Bernhardt gave a series of talks you can find on the web. They're really good. Where he spends the first half talking to Ruby developers about why functional programming is a good thing. Then he goes on and shows an example in Ruby. We're going to use that example. I'm going to do it in Elixir. The basic user story is, for all active users, if an account has expired, then send email to that user. Okay, on to the code. Hope this shows up here well. We're going to isolate the side effects. First, the first version, we're going to look at it as an untestable code. Then we're going to look at how to test it with global stubs. I don't recommend either of these. Then we're going to solve it with local stubs. And finally, we're going to do some pure-impure separation on that code. Starting at the beginning, untestable. So in this code, we're going to get a user. We're going to get all of them out of the database. We're going to apply some rules to that. We're going to filter to find the active ones, and then we're going to reject the ones that are paid up. Once we have a list of our problem users, we're going to send them one at a time to the user mailer to tell it that there's a billing problem. So we can see there are 3 areas where we're having side effects. We're getting the users out of the database, we're talking to this user mailer, and we're doing the system time. Now, for the purposes of this talk, we're going to just solve for the user mailer billing problem. The same technique can be used for all the rest of them, but we'll just focus on one. We'll do that with putting in global stubs. And so with the global stub, we would do a pretty common operation that a lot of beginning Elixir teams use is just go to the application, get environment, which is a global space, and look up the user mailer here at the location links mailer. If there's nothing there, it will use the production version of the module named user mailer. And here we go, we can put that in where we were using it directly before. We can now make this pluggable. This is kind of nice because over in our test we can create a stub, user mailer stub. It has billing problem as a function, and since each test runs in its own process, when we send a message to self in the test gets that message back. We are going to send a tuple, and there we go. We're going to send the tuple billing problem with the argument to let the test know that something happened. Now in the test, we can put something in the database. We're going to put the user, an expired user that is active, into the database. We're going to get the old user mailer, save that off, put our stub in its place, and let's follow the Boy Scout rule and tidy up afterwards and put the old mailer back in that global space. This is global, remember. We finally get to the test, the code under test, and when we run that, we get our message back saying that it executed. Good. We were able to do that. Well, there's a number of troubles to this. One is the setup is quite large. Yes, we can extract this. It makes it easier to call a setup function, but it's still it's still big. It still has to happen. Others, it's global. We can't run more than one test at a time. Another problem that I've seen on teams is it's really, really easy to forget that on exit to clean it up. What ends up happening is if you forget that on exit, some other test somewhere is going to break, and you won't know why. It's going to be one of those flaky instances. So let's solve that. We can do that with local stubs. With the local stub, the setup becomes a lot simpler. All we do is pass in that stub. There's no global setup, there's no global mess that we're leaving behind. And in our function under test, we will take that user stub, and if it doesn't exist, we default to the production version. So by default, it'll do the right thing. In fact, we should prefer local stubs. As Jose Valim says in his blog post, Mocks and Explicit Contracts, passing the dependency as an argument is much simpler and should be preferred over relying on configuration files and application get environment. But we still have some problems here. Single responsibility principle tells us that a function or a module should do one thing and one thing well. When we look at this, we actually find out it's doing a lot of things. It's getting things out of the database, it's applying the business rules, it's then sending. What we're doing here is mixing pure and impure. And that doesn't make me happy. Zach, yeah. He actually brought that one up. Yeah, but this doesn't make me happy. So let's do that. Let's separate these guys out. We can pull out our business rules into an overdue module. The user's function gets the business rules that we're interested in. Well, the really nice thing here is that since all of these are pure, testing them becomes super simple. We pass in some data, and out comes the data. All the different conditions that are implied by this code, we can build with tiny little tests that run super fast, all in memory. Good, we got that part tested. What about the impure part? We want to make sure that everything connects. We're not going to be interested in the business rules, so we're going to just create a pass-through function that says just make all of them. Just pass through all of the users that we give you. Therefore, if one goes through, all of them will go through. In our code then, we have that filter that just passes them through. We have one test that proves everything connects. There is no conditional logic here. One test is all we need to make sure this is going to work. So, how do you build these tests? Well, there are two styles of test-driven development. There's the outside in and inside out. You saw that one coming, right? Outside in, you start with the user interface or the API, and you write the real code for that. And suppose real code 1 requires real code 2. Well, stub that out. Create a stub of real code 2. Now we go and implement real code 2. It may need real code 3, but we'll stub that out. And we keep going as we go closer and closer to the database and our core logic. That's also known as the London style. Inside out is known as the Detroit style. And for that, you write a test on your core domain logic first. And if you have more core domain logic, you write tests for that. So the rule is if you need setup code that is pure, you can use that directly. So to test pure 3, for instance, you can go ahead and use pure code 2 to do that setup. It's all probably in memory and running fast. And although this code might start looking this diagram might start looking a little complicated, the code itself is going to be cleaner. So when you're testing side effects, you can also use the pure code to set up your side effect tests. And you work your way back from the core domain back toward the user interface or the API. Sometimes you'll need stubs. They're not outlawed. You're allowed to use those, but we tend to use a lot less. Now, there are a number of patterns to set up your core domain, to make it disconnected. Some of those are available in the area of domain-driven design, and recommend that people look into the building block patterns of domain-driven design to make this stuff happen. There's also some Elixir books that talk about this too. To recap, new code. Separate functions from procedures. Keep your logic pure. Test-driven development can help guide you in this way. And investigate some of the patterns of domain-driven design, because they're also a big help in moving in this direction. For old code, find your large and global setups. Break that down to use local stubs instead. Move toward using pure functions, and protect your code with chainmail unit tests. Protect what is precious to you. Thank you very much.